Hey guys, back on the 492s. Think I've had two cuts since last time you guys have seen them, and it was kind of interesting how it all came about. But we're inching up on gains very slowly. But it's whenever you're developing a port, you got to try to figure out where in the port is holding you up. Is it the valve job? Is it the chamber deshrouding? Is it the short side radius? Is it the pinch? What is it? There's something in there that's holding you up. So I did some calculation on the pinch that was there. Okay, we were just squeaking 264 at 800, but in reality it's more like 255 at 600 lift, right? Okay, so take a look, some quickie calculations. It's good for 260 CFM, that pinch. So somebody's going to say, and we've said this before, Charlie, it's absolutely impossible to get 264 through an opening that only allows 260 through. Okay, let's take a look at it again. I'll use this port because there's some light on it. Our minimum is in the port a bit, right? And you can see the curve on that. Now, since the air is speeding up there, right? What's going to happen to the pressure? One of the reasons I take air speeds of the pinch, right? And anytime you take air speeds on the sides of the pinch, one side is always faster than the other, which is kind of interesting. Curved side seems to always be faster. So we increase the airspeed. What happens to the pressure? Pressure drops. So are you pulling 28 inches at that point anymore? You're pulling more than that. So it is theoretically possible to pull more than 264 CFM through a pinch that's only is only sized to go 260 CFM. So I figured that was holding me up. So let me pop this valve out so I can show you. Okay, so I opened up the pinch, but in reality, you can take some out of the center wall. You can only take as much out of a curved wall as you can until you're out of material. You can take some out of the top, and of course everyone says don't take anything out of the bottom or the floor, but in reality I had to take some out of the floor as well. Charlie, why would you ever do that? Because I needed the area, that's why. And you can see I made a couple cuts and I did some calculations. I'd really like to get these around 283. If Larry Moe says they're good for 283, 285. That's what I'm shooting for. Okay. Since we're already down its throat, let's take a look at our dicum. See if we can zoom that in a little bit. Okay. Overall, that's got a decent pattern on that wall. Come on. It's relatively wide. Now, I may be able to make that wall a little bit straighter. I have some metal still there. I can make that. I'm going to try to make that dead straight. But I'm going to pay attention to my airspeeds at the same time. Okay, it looks like I squirted a little more dicum than usual, but you can certainly see how it's hitting the chamber. This chamber I don't believe is deshrouded as much as the 041Xs that I got to 275 CFM. But deshrouding the chambers, I'm going to go a little at a time with, only if I absolutely need to. I'd like to keep these a little bit tighter. Let's take a look at the bench and see what that looks like. It looks like I squirted a lot of Dicam, but you can see a little bit of the curve. And these had plenty of swirl. In fact, way more than we actually need. But let's compare the last couple cuts. All right, this was just opening up the pinch, okay? And in doing so, you can take a look at our pluses and minuses. There's only a help at the top end and not even a lot, okay? Only a couple CFM. Did it do anything with our swirl? Hit or miss, a little bit more swirl on this. So we got a lot of minuses. We got 7 minuses, and we got 8 minuses. We only got 4 positives. So not really a winner, right? Let's take a look at our airspeed on the pinch. Noticeable difference of the airspeed to pinch, which we should get because it's a bigger hole, right? All right, let's take a look at our center of cylinder and cylinder roof side. Reverse these. Okay, they changed considerably. That was a part that I wanted to talk about. By changing one part in the port, take a look at the difference where the air flows in the port now. I was thinking about this today at work, and I'm like, that's what I need. I need to talk to the guys about this. Take a look at the difference in the airspeed of the roof. Here, 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 right? And take a look at our short side radius here, right? 368, 375, 377. Take a look at how much higher they went up. Okay? So why didn't we get a huge gain? Well, what I think happened was it started to push more air across the short side radius. Now, the short side radius wasn't mega wide. It was pretty wide. But when you're developing a port, you don't want to cut it super wide to start with. You gotta go little by little and figure out what's the best way to go about it. And I think it's really interesting what happened on the roof. Right? A lot more came to the center of the cylinder. And that was, we had to worry about on this port, right on this edge here. It gets a little thin. So I'm going to talk about the exhaust for just a minute, because from last time you saw the exhaust flows to I did a little more work on it. I lost a little bit up top. Gain, 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 gain. I think I'm calling it quits on that. That's pretty serious, that port. I mean, take a look at our exhaust ratio. I'm not an exhaust ratio guy, right? You got 262, 220. All right, that's a high exhaust ratio. We don't, at this point, the intake needs a lot more work than the exhaust. I'm going to say the exhaust is good. It's still nice and thick. It's got a nice shape to it. I think I'm done with the exhaust at that point. Okay, so after we did these flows, only went up a little bit here and there, I decided to, my notes are wider short side radius, which you have to remember. The short side radius is a compound curves, and the Sonic has a hard time with compound curves. So you got to kind of really be careful. You can't just gouge it out. You'll just make sprinklers. So I widened the short side radius a little bit more. I changed the layback a little bit due to the air speeds. And I gave a little more work to the center of the cylinder on the roof. And the reason I did that is because it was 30 feet per second faster on the roof. Okay, so let's put these next to each other. Okay, plus plus minus plus 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 plus. Obviously I'm onto something, right, guys? Just by opening up the pinch didn't help. Yeah, I got a little more at the top end, but not much. Remember, this pinch is now good for 283, so we know the pinch isn't holding us up anymore. It's other parts of the port that are holding us up. Now, did we change our swirl a whole lot? It looks pretty darn close, right? Not really a big difference. So a relatively stable swirl curve, but we're up everywhere. Now, it's still nowhere near where I want it to be. I'm still looking for another 20 CFM out of this thing. Didn't even waste my time taking speeds on the pinch because that's done. But what happened here? Right, we were almost 30 off there. We're only 20 off now. So it's a little more even on the roof. That makes a difference. Take a look at what happened with our short side radius. We went from these numbers. We definitely gained some speed across the short side radius. So I made it wider, I laid it back, and gained speeds. So what is that telling us, guys? Getting more air across that short side radius now. All right, I wanted to show you the pattern on the valve, which is quite cool. Right? Gotta realize the valve goes in this way, right? So this is facing the airstream, and it's going to get whacked with the dicom, and you can see it go around the stem. You can see just a touch on this wall, not a huge amount. But yet, when we do our air speeds, that part of the roof is faster. That's 210. The other side is 190. All right, guys. Just a little one tonight. These will get a little more work. I got to pack up a couple jobs this weekend. And thanks for hanging out.